Hey, so here's the do now from today. Hopefully you saw this in class already. Find the length of the missing side x. Leave your answer in radical form. Okay, hit pause till you got this done. All right, so here is what we ought to come up with. The 6 is the hypotenuse. We have to use that as c. So we do x squared plus 5 squared equals 6 squared, and end up with radical 11. No decimals on this one. We want radical form. So just go ahead and when we square root 11, we'll leave it as the square root of 11. So what we're looking at today, what we got to do now out of the way, are the 6 trigonometric ratios. Now you are familiar with SOHCAHTOA. We've been using that up until just yesterday. Sine, cosine, and tangent are not the only trig ratios. So if that's what you were misled, if you thought that was it, there are more trig ratios. We're going to learn the other ones today, and our learning target is you'll be able to evaluate the remaining 5 trig ratios if I give you one of them. So first thing we ought to do is learn what the 6 trig ratios are. So here are all 6 trig ratios laid out in a very special format. You should write this into your notebook, keep track of this, write them down in 2 columns like this. So the 3 trig ratios we're going to learn about today are reciprocals to the 3 that we've already learned. And they are less common, obviously. You've never heard of them before, but incredibly useful, very important. So each of the 3 trig ratios we've already learned has a reciprocal. They've got super weird names, and the naming conventions seem to follow random patterns that are not the same all the time. So um, anyway, let's go one pair at a time. So we know sine is the opposite of our hypotenuse. Its reciprocal is named cosecant, and its hypotenuse over the opposite. Each of these pairs, reciprocal pairs, always has the prefix co on only one of the names. That's the way I remember it. So sine and its reciprocal starts with cosecant. Cosine has a reciprocal named secant. So there's kind of some name similarity going on. And when you got sine and cosine, we already know those. And then these new ones, cosecant and secant, there's some similarities on both sides, both columns. Okay, well, in cosine, the prefix co is on the cosine. And then with secant, we can keep track which one goes which because there only has one of them will have the prefix co. And then the last pair, tangent and cotangent, these ones are easy to keep track of because the names are the same for the reciprocal that have tangent shows up in both. And cotangent is the adjacent over the opposite. Okay, so if we have them written in your notebook in this format, then the reciprocals will be straight across left column and right column from one another. And so when you refer back to your notebook, up until the time when you have them memorized, it will be easy to keep track of which one is which. The names are the important thing we have to memorize. If we keep the names memorized and the ratio that is used to create that, hypotenuse over opposite is cosecant. Hypotenuse over adjacent is secant. Adjacent over opposite is cotangent. So the more we use them, the easier it is to remember them, but we'll probably just need to spend some time memorizing. All right, so let's look at putting them to use. Here is using one trigonometric ratio to find them all. I love that. The textbook actually says that way. It always reminds me of Lord of the Rings, the one ring to rule them all. It's the one trig ratio to find them all. So here we go. Let theta be an acute angle such that sine of that angle is 5/6. Evaluate the other 5 trigonometric functions of theta. They're often referred to as trigonometric ratios. They're often referred to as trigonometric functions or trig ratios. I prefer to call them trig ratios because it reminds me that they are in fact ratios, as we can write them as fractions. So in these problems, there is no need to find out what the angle is. We do not need to know that theta is blah, blah, blah degrees. That is just not something that is necessary at this point. Certainly something we can do, but it is not necessary here. So the first thing to do is to draw the triangle. So I have an acute triangle drawn ahead of time, and I can choose which angle I want to call theta. It could be the lower left one, could be the upper right one. Either way is totally acceptable. There's really no difference. Just kind of the drawing will look different. But since I have more space for drawing, I'm going to go with the lower left one. So here's my theta. And now I can use the information I'm given. Sine is opposite over hypotenuse. So when it tells me that sine of theta is 5/6, it's telling me the opposite side is 5 and the hypotenuse is 6. So I'm going to label those. And before I can find any of the other trig ratios, I will need to get the missing side length down here. All right, so I can call it x, and then I could use the Pythagorean theorem to find the length of x. Interestingly enough, we just did that problem as part of the do now. So we know that x equals the square root of 11 because conveniently enough, someone asked you to find that just a minute ago. All right, so now that I have all three sides of my triangle labeled, I can use them to create these ratios. So I'm going to scroll down here, and sine is opposite over hypotenuse. We know that because we just saw it like 2 seconds ago. And so to create this ratio, I need a fraction line, and I need to find the opposite side for my little graph walker. Opposite is 5. Could label them, in fact. Get a different color. Opposite, adjacent, hypotenuse. All right, so the opposite is 5, the hypotenuse is 6. So put 5/6. Okay, next one says cosine, which we remember is the adjacent over the hypotenuse. The adjacent is square root of 11. Hypotenuse is 6. We're going to leave it in radical form, and we're going to leave all of these as fractions. So that is final form right there, square root of 11/6, or radical 11/6. And then let's look at tangent. The tangent is opposite over adjacent, and opposite 5. Adjacent is the square root of 11. You probably remember being taught at some point in the past that it is bad math grammar to leave a square root in the denominator of a fraction, which is true. That is bad grammar. However, most of the problems in the one-map assignment are not going to care. If you put in a radical in the denominator, it's not going to be an issue. If you wanted to have good mathematical practices, you could rationalize the denominator. We'll just take that radical 11 and multiply both the top and bottom by radical 11. Whoops, sorry, rogue cursor. And when that happens, I'm going to multiply straight across the top. So this is legal mathematically because I'm not actually changing anything. If I divide the square root of 11 by itself, it basically is 1, right? Any number divided by itself equals 1. And if I'm taking this red fraction and multiplying it by the black fraction, which is 1, multiplying the red number by 1 does not change its value. So I have not actually changed what number this is. It's going to have a different appearance. That's the only reason I'm doing this. So multiply straight across the tops, 5 times the square root of 11. It's 5 radical 11. And in the denominator, I'm going to get the square root of 11 times the square root of 11, which would be the square root of 121. I'm not going to write that down because I don't have enough space here. But the square root of 121, oh, that's a perfect square. And I know that 11 times 11 is 121. So when I do that square root, I get 11. Okay, so this is mathematically correct. 5 radical 11 over 11, also less helpful for me to continue doing the rest of this problem. So you can enter either form into the WAMAP. But let's continue into column number 2. Cosecant is the hypotenuse over the opposite. The hypotenuse is 6, and the opposite side I have labeled, that's 5. Secant is the hypotenuse over the adjacent. Conveniently, I've got all of the ratio definitions labeled on this page, but if you don't have them memorized yet, then you want to keep your notebook handy so you can look back and refer to what ratio you need, what side lengths you need to put into that ratio. Okay, the secant. Secant is hypotenuse over adjacent, and I can see this hypotenuse is 6 up here, and the adjacent is square root of 11. And lastly, cotangent is adjacent over opposite. So my fraction is going to be the adjacent side is square root of 11. The opposite side is 5. Okay, so you can just create each of these ratios from scratch. That is one approach. Second approach is after you have done the left column, sine, cosine, tangent, you can just take those fractions and flip them to get the reciprocal, and that'll give you column 2, as long as you have named them according to the format that we have in our notes right here. So you have to have cosecant on the top, secant second, and cotangent third on the left column to match sine, cosine, and tangent in that order. And then you could just flip. Instead of 5 over 6, you can have 6 over 5. Instead of radical 11 over 6, flip it 6 over radical 11. Instead of 5 over radical 11, radical 11 over 5. If you've rationalized the denominator in tangent to get 5 radical 11 over 11, that's awesome. It makes it a little bit harder to do the reciprocal, because if you take 5 radical 11 over 11 and flip it, that puts the radical back in the denominator for cotangent, and then you'd have to re-rationalize. Or you could remember, oh yeah, what I started from was 5 radical 11. You could flip that one.